Hello students, we are now on the verge of completion of the course. Today is the 60th class of this dairy and food products, dairy and food process and products technology. And since we have covered a lot, I feel that I should also share with you some of the data which we generated in our laboratory classes or in our rather I should say PhD programs, because these are authentic data, our students have done it. And let me share with you manufacturing some of the both dairy and food products. I am not saying in that entire gamut of the dairy and food products we can show, but few of them which we have done in our lab by our students. Again, they got their degree PhD, so the data are authentic, right. So, we come to our 60th lecture, that is flow chart for manufacturing some dairy and food products, right. So, this is some flow charts we will be showing you, and these data are authentic, right. So, flow charts, process and material flow, right. So, in this first we say that chana from buffalo milk, right. We had taken buffalo milk, and from that we have quantitatively formed chana, right. Chana we have said earlier, that is the acid coagulation product of milk, right. So, that acid coagulation, how best you can get maximum chana, so that is debatable, right. The reason being, the milk with which you are starting, that milk will contain different fat content and SNF. So, until and unless you have the source or raw material identical, your end product will not be. So, that is why it took several months or years to come to this statistics or data, and we could make a streamline, provided again you have the input or intake of the material identical. So, we took buffalo milk, that milk 1.03 kg we had taken, and that contains 65.6% moisture and 6.3% fat, and its acidity level at that moment was 0.15. We said earlier that milk between 0.1 to 0.28, the milk is taken best. 0.1 is the best, 0.28 is gradually going to worse, but up to that limit it can be accepted. So, here our acidity level is 0.15. So, it is a very reasonably good milk, right, having 6.3% fat and 85.8% moisture, 85.6% moisture, right. So, this is the starting. Side by side we have taken citric acid in the solid granules. So, citric acid 4.67 10 to the minus 3 kg per minute with a flow rate, right, because this is a continuous chana making process. So, that is why per hour it has come. or per minute, kg per minute, that is flow rate has come. So, it is this is mass flow rate 4.67 × 10⁻³ kg per minute is taken as the granule, and water is taken 0.21 kg per minute, right. So, they are now mixed. So, that mixing is done. So, after mixing, this makes citric acid solution containing 0.21 kg per minute solution, because your water was there and the entire acid is soluble in water. So, you got a total solid of 2.77%. Then the entire solution is heated in a U-tube heat exchanger. So, U-tube heat exchanger is looking like, so you have a U-tube like this. So, this type of heat exchanger is used for heating, right. So, U-tube heat exchanger, length 2 meter, tube ID/OD is 6/9 millimeter, right. So, that we prepared or made in our lab, and this side, this is already ready, this side milk has come. So, what we are doing? We are now heating that milk. So, milk heating is done in indirect type of helical tube, right, helical tube like this helix, right. So, helical tube is this way, it is a helix is being formed. So, in a helical tube heat exchanger, tube length 4.96 meter, mean diameter of the coil is 120 millimeter, tube ID/OD is 6/9, right. Then this is heated by saturated steam at 1.13 bar at 103 degrees centigrade, right. At 103 degrees centigrade it is heated. So, then what you get along with this, what you get? You are getting this hot milk, then this is cooled. So, cooling by indirect type helical tube heat exchanger, tube length 7 meter, mean diameter of the coil is 120 millimeter and tube ID/OD is 6/9 millimeter, right. There it is being cooled, cooled by water, water at a rate of 1 kg per minute with a temperature of 28 degrees centigrade, right. So, now you got this cold milk and the temperature of the milk comes to 70 degrees centigrade. So, you got 70 degrees centigrade milk and citric acid solution at a rate of 0.21 kg per minute, which is brought to 70 degrees centigrade, warm to 70 degrees centigrade, because if it is not 70 degree, if it is 70, then again that heat will be either exchanged between them, that is not desirable. So, both are at 70 degrees centigrade and then they are mixed, the citric acid and the milk, they are mixed in a vertical tube where the milk is where milk acid mix moves upward. Tube length is 80 centimeter, tube diameter is 4.5 centimeter and the residence time is 1 minute, right. So, when we kept it, then we the milk gets precipitated or milk gets curdled. So, there by gravity separation in a muslin cloth they are separated, and we get that chana to the tune of 0.218 kg per minute. This is minute, 218 kg per minute, having a moisture content of 50%. So, this is another thing which is required, that this rate is 0.218 kg per minute, not in, this is minute. So, m got deleted. So, 0.218 kg per minute with a moisture content of 50. So, this moisture content will tell whether it is 0.218 or 0.25 or 0.19. So, if it is less moisture, then less total. If it is more moisture, more total. So, then the quantity will be dictated by the moisture content, right. So, it is cooled and this is separated, and we get weigh 1.01 kg per minute, right. So, this is how chana is being made, right. So, now let us look into another product, that is paneer. Paneer is made from again chana or milk. So, here we are taking milk 1 kg with a moisture content of 83%, fat content of 7%, acidity 0.17% lactic acid, right. This is the starting material. Then heated to 95 degree centigrade. The detail we have shown in the previous one, that how our heat exchangers are made. So, those we have kept now aside, but the similar things have been used. So, heating is 95 degree centigrade, then cooled to 70 degree centigrade, and this side we have taken citric acid 4.54 10 to the minus 3 kg, water 0.2 kg, and they are mixed, then heated to 70 degree centigrade. So, this citric acid solution and milk, heated milk, both at 70 degree centigrade mixed and at 70 degree centigrade, and it allowed to settle. Then milk acid mix of 1.2 kg with an acidity of 0.66% lactic acid is obtained, and we get a gravity separation through a muslin cloth at around 60 to 70 degree centigrade. So, whey comes out around 0.953 kg with a moisture content of 94.5%, and we get chana around 0.252 kg with a moisture content of 94.5%. Right. Earlier I told you that the higher the moisture content, more will be the quantity. So, here also you see that 0.252 kg we got with a moisture content of 94%, right. Then it is centrifugally separated. Centrifugal pressing by double wall basket it is done, and this centrifugation is done between 30 to 60 degree centigrade. Then we get whey out from by this centrifugation, we get whey out, where we get 0.054 kg of whey with a moisture content of 88.9%, and we get pressed chana 0.198 kg with a moisture content of 43%. Then it is chilled. So, chilling pressed chana inside the centrifuge by chilled water at 40 degree centigrade in the ratio of 1:5, that is 1 part of chana to 5 part of 40 degree centigrade water for a time period of 24 minutes, and we get some milk solids around 0.009 kg that is wasted, and we get rather that is one which we get rather milk solid rather gets wasted when it is going out with the water, and some water around 0.016 kg that is also coming out. Then we are while we are pressing that water comes out, some solids comes out, and we get paneer around 0.205 kg with a moisture content of 49.8%, right. So, this way you can make the paneer. Then we come to another product called sandesh. This is a very popular in Bengal, maybe all over the country. Sandesh is one very popular product made from milk. So, sandesh we are making milk taking 1 kg with a moisture content of 87.9%, having fat of 4%, total solid 12.1, and this is heated to 90 degree centigrade, cooled to 70 degree centigrade, side by side citric acid taken 3.44 10 to the minus 3 kg with water of 2.25 kg. They are mixed, heated to 90 degree centigrade, then cooled to 70 degree centigrade. Citric acid solution of 1.376% and 0.25 kg, right. And then they are mixed for a minute and settled at acidity of 0.4% lactic acid. Then they are separated by gravity. By gravity separation, we get whey out of 1.06 kg having a moisture content of 92.2%, and then we also get chana of 0.193 kg with a moisture content of 62%, and then it is centrifuged. Centrifugal separation is done by basket centrifuge at around 1500 rpm for 8 minutes, right. Earlier we did not mention rpm of this centrifuge. Here we are mentioning that centrifuge is working at 1500 rpm. Then we get some whey also out around 0.052 kg with a moisture content of 84.6 kg, and we get the mixing plenary gear at 60 rpm for 5 minutes, where this mass and the sugar is added around 0.056 kg. So, this sugar is added to this solid mass and mixing in a plenary gear for 60 rpm for 5 minutes. Then kneading is done. Only this kneading is done. No, this was also done automatically. No manual. All are done automatically in 75 rpm screw kneader. Right? This screw kneader also was developed at our place. So, this screw kneader is kneading. So, kneading is one of the important step for making sandesh. You might have seen in the confectionery that they are kneading it like the one which is done at home when bread is being made. So, that is also being kneaded, right. So, this kneading is done at 75 rpm in a screw kneader, and this kneaded chana with sugar mixture we get 0.197 kg with a moisture content of 35.6%, right. Then it is cooked at 75 degree centigrade for 4.6 minutes and then cooled to 25 degree centigrade, and this is done in a shaping vented extruder. shaping vented extruder. The extruder was like this and the top is open, a part of the top is open. So, that is the shaping vented extruder, so that the water or moisture can easily go out, right. So, by this we get sandesh, and this sandesh, since we did not have sandesh generally available in the market of different shape, different product, but different variety, but ours one was a cylindrical shape, because this from there when it was coming to a shaping machine, that was only cylindrical in shape. So, small cylinders like this we got, and the taste was same as it was available in the market, but the shape and size, that was our only drawback, that it could not be like the one which is available in the market, because they make it in a mold by hand, but here no hand was made. Right from this up to this on this preparation, entire thing was automatic and no hand was put in between, and that is why when we got the shaping, we wanted to give the shape was a cylindrical shape, and the taste was as good as the sandesh, and storability was also for couple of days, because moisture is very high, sugar is very high, right. So, then we move quickly to another very popular one, that is called Rasogolla making, right. This Rasogolla making is again from cow milk of 1 kg with a moisture content of 88.7% and fat content of moisture content 8.7%, fat content 0.033, acidity is 0.016 lactic acid. I think this made is 1 kg. So, that is why it is made the 3.3%, fat content is 3.3%, right. So, that is heated to 95 degree centigrade, cooled to 70 degree centigrade. Parallelly, citric acid solution you have made, citric acid 3.44 × -3, water 0.25, mixed, heated 70 to 70 degree centigrade, got the citric acid solution 1.376%. Then they are mixed and settled for 1 minute. Acidity level is 0.14%, and you got the whey of 1.107 kg with a moisture of 95.5%. This is done through gravity separation, and after separation you got the chana. Chana is 0.146 kg, and moisture content is 55%, right. Then you got the basis, that is the chana, and this is kneaded. A little water is added around 0.011 kg, so that it becomes easy for kneading. Then kneaded chana of 0.157 kg with a moisture content of 58% is made to balls, and these balls were made 15 numbers, 10.46 gram each, and then little water, this is there is an arrow, little water comes out during cooking. Cooking is done in 2 liter 50% sugar solution for 20 minutes. Sugar was added 0.043 kg, and then you got cooked chana balls 0.252 kg, total solid 0.109 kg with a moisture content of 56.6%. Then it is soaked in 1 liter 50% sugar solution for 4 hours at 30 degrees centigrade, right, for 4 hours at 30 degrees centigrade. Then you got water out around 0.0545 kg, and you also got out sugar 0.016 kg. Then you got Rasogolla 0.313 kg, right. This 0.313 kg Rasogolla which you got, that is very good in taste, and that was rather very good in taste, and the shape and size was also absolutely perfect, right. Then sweetened pineapple slice very quickly because time is very limited. So, pineapple 1 kg is taken, then peeling, coring and slicing to 8 millimeter thick, water goes out 0.3 kg, then dipping in 2% ascorbic acid, then dipping in 62 bricks sugar at 47 degrees centigrade for 4 hours. Syrup is to slice is 4:1. Some water comes out around 0.398 kg. Then washing in water, open steam 4 is given, right. Then 4 minutes. Then it is hot air dried, water vapor goes out. In this case sugar is also added before that. Water is coming out 0.176 kg. So, hot air drying you get sweetened pineapple slice 0.256 kg moisture content around 11%, right. And then last is shelled cashewnut, that is roasted cashewnut. Makhana is also there. So, roasted cashewnut is prepared roasted cashewnut 1 kg, shelling by a plate mill 300 rpm 300 millimeter diameter, manually separated, shell comes out 0.7 kg, and unshelled kernel is 30% feed, and then cashew kernel 0.3 kg with a moisture content of 18.5%. Then oven dried 80 degree centigrade for 6 hours, dried cashewnut kernel 0.26 kg with a moisture content of 6%. Then manual peeling is done, cashew kernel with 0.25 kg having moisture content of 6% is obtained. From there it is open steam is made for 4 minutes. So, some rejected one is 0.25, split ones is 0.055 and broken one are 0.068 kg, but whole cashew you got 0.125 kg, right. So, the last one which we have is makhana, and makhana is a very popular in North Indian dishes. So, what you make that from hot air drying in tray dryer at 60 degrees centigrade, right, some water vapor goes out, dried makhana seed with a moisture content of 0.25 moisture content of 25%, then grading by set of sieves, some are rejected, graded makhana seed, then preheating in screw type conveyor, water vapor comes out, the hot makhana seed of 21% is obtained, then it is tempered, roasted in screw type roaster, then popping is done in centrifugal popping machine, then manually separated, seed coat comes out, then popped makhana is obtained, and this is then graded, then you get under popped, over popped and properly popped makhana, then that is polished, some red pericarp is obtained as a byproduct, then packaging in polyethylene lined gunny bags, and then this you get processed makhana, right. So, by this we come to the end, and one thing which I would like to share here with you, that whatever we have taught till now, we have tried our best, but please go through repeatedly and appear in the exam. So, this course is under MOOC, is university approved, MHRD approved, AICT approved, EGC approved. So, you can compensate some courses at your place, and you can talk to your teachers or head of the departments or principal, so that these courses, if you appear and give the exam, get the certificate, that can compensate your normal coursework, right. So, all the best for future. Hope you have enjoyed the classes. Thank you.